Hello, we are discussing about GATE 2015 ECE paper. In the circuit shown, the initial voltage across capacitors C1 and C2 are 1 volt and 3 volts. So initial voltage V1 is equal to 1 volt and initial voltage across C2 is V2 is equal to 3 volts. The switch is closed at t is equal to 0. The total energy dissipated in the resistor R until steady state is reached. Okay. So let us assume steady state is reached. So from the initial t is equal to 0 to steady state reached, how much energy is dissipated in the resistor R, that we are going to calculate. So energy dissipated in resistor R is equal to difference in energies across capacitors, difference in energies across capacitors. So that means what is initial energy across the capacitors? Total energy initially, that is at t is equal to 0. So t is equal to 0, and final energy, what is the final energy at t is equal to infinite? So across the capacitor, what is the initial energy and what is the final energy at t is equal to infinite? How much difference you are getting? That difference is nothing but energy dissipated in the resistor. Okay, and we know energy across a capacitor is going to be calculated using half CV square. This is energy across a capacitor. So for that one you must know the capacitor value as well as voltage across that capacitor. Okay, so first case 1, that is initial at t is equal to 0. At t is equal to 0 minus, for example, at t is equal to 0 minus, switch is open. It has not closed. By that time both the capacitors are having different voltages, V1 and V2, and no current flows. Okay, so current flowing through it is 0. I is equal to 0 as it is switch is open. Okay, and the voltage across capacitor is different, voltage across capacitor C2 is different. So total energy is equal to energy due to C1 plus energy due to C2. So E at 0 minus, which is nothing but initial energy, is equal to half C1 V1 square plus half C2 V2 square. That means half into C1 is equal to 3 into V1 square is 1 square, and half is already taken common. C2 is equal to 1 farad into 3 square. So this will be equal to 1 by 2 into 3 plus 9, that is 12 by 2, which is nothing but 6 watts. Okay, 6 joules. So this is 6 joules is the initial energy. Initial energy is 6 joules. Second, case 2. Under steady state. Okay, under steady state. Steady state is reached. Okay, at t is equal to infinite. So under steady state capacitor acts as open circuit. By that time simply it is replacing with open circuit, even though the switch is closed, but these two are going to be acting as open circuit. Even though the switch is closed, but both the capacitors are now acting as open circuit, so that again current flowing through it is 0. So voltage drop across this resistance is 0. Okay, I is equal to 0. So voltage drop across resistor is 0, that is nothing but short circuit. So simply it is acting as a short circuit, and so that voltage across capacitor is same as voltage across capacitor C2. So voltage across capacitor C1 and voltage across capacitor C2 is same at this point. So say it as Vx. Assume. Okay, we don't know the exact voltage. To calculate Vx, we must equate charge during initial and charge during steady state, that is final. So charge across the capacitor cannot change. Okay, so Q initial is equal to Q final. We know the general equation for Q is equal to C into V. So Q initial must be equal to Q final. C into V is nothing but C1 V1 plus C2 V2. Initially both capacitors are having different initial voltages, and final voltage you can write it as C1 into Vx, voltage across capacitor, plus C2 into Vx, which is nothing but Vx if you take common, C1 plus C2. So you can get it as C1 V1. Okay, C1 V1 is, C1 is 3, V1 is 1. So C1 V1 is 3, C2 V2 is again 3 volts, 3 coulombs. So that is equal to Vx into, okay, C1 plus C2. C1 plus C2 is nothing but 3 plus 1, which is nothing but 4. So Vx is equal to 6 by 4. 6 by 4 is nothing but Vx value. Vx value is 6 by 4, which is nothing but 1.5 volts. So now the voltage across the capacitors under steady state is 1.5 volts. Initially they may be having different voltages, but under steady state, whenever the switch is closed, both are maintaining the same voltage, as the resistance is going to be acting as short circuit. Since under steady state capacitor act as open circuit, that makes zero current to flow in that circuit. Zero current means zero voltage drop across resistor, so that will be treated as short circuit. So both capacitors will be at the same voltage. That voltage we have calculated as 1.5 volts. Now final voltage we are going to calculate. Now we will calculate the final voltage. So final energy, now we are interested in the calculation as under steady state energy at t is equal to infinite, that is equal to energy due to C1, energy due to C2, which is nothing but half C1 Vx square plus half C2 Vx square. So that means half into C1 is 3 into Vx is 1.5 whole square, which is 1.5 is nothing but 2.25 plus C2 is 1 into Vx square is 2.25. So this will be equal to 4 into 2.25, which is 9. 9 by 2, that is nothing but 4.5 joules. So energy at infinity, final energy, this is final energy, and initial energy is 6 joules. Final energy is 4.5 joules. So the difference is going to be dissipated in the resistor while it is approaching the steady state. So the difference is nothing but 6 minus 4.5, which is nothing but 1.5 joules is going to be the right answer. 1.5 joules is the right answer.